Today we are going to discuss about the advanced security architecture modeling. So where we are going to talk about SOA, IoT, SCADA and SABSA kind of topics. Now these topics are very much testable in both the CISSP as well as it is also going to be helpful for those participants who are also preparing for the ISSAP certification. Okay, so this domain 2 security architecture modeling is actually a dedicated domain which we have in the ISSAP section. Okay, so now when we are talking about your now when we are talking about your security architecture and modeling. Now, when we are talking about your security architecture and modeling, what is a security architecture? It's a set of models, methods, and principles which align with your objectives to keep your organization safe from cyber threats. So, a thorough security architecture, a business requirement are translated into the executable security requirements. So, now whenever we are defining a security architecture, okay, so first thing we need to understand, like when we talk about the architecture, okay, we have a two types of architecture. We have an enterprise architecture and we have a security architecture. Now when I am talking about your enterprise architecture, live examples of your enterprise architecture, we have your Zachman framework, we have a TOGAF. These are mainly architectures which are used for the enterprise architecture. Okay, now when we are talking about your security architecture, we have a SABSA. Okay, so now if you see, basically as a security architect, our role is to identify the business drivers and objectives. Okay, identify the business drivers and objectives. Then we need to define a security program and architecture strategy. So we need to define the security program and architecture strategy, so where we need to translate whatever the business drivers and objectives. So we need to translate the business requirements into the security attributes, define a security architectural plan where we need to define the framework, okay, which is going to help the organization to achieve their vision and mission. And finally we review and revise, so we monitor and improve agreed security architecture framework and controls. So basically, the if we have to take a much more detailed example, okay, if we have to take a much more detailed example of security architecture, we can take an example like where we define the requirements. First we define the requirements, so whenever we have to build a system, we define the requirements. Then we basically design, so here we define the product designs and all. Then we basically create a high level architecture, so how the data flow and all is going to look like. We develop individual modules, okay, we develop individual modules and then we code. After we do the coding, we basically do the testing. So we do the unit testing, integration testing, system testing and acceptance testing. So this is like when we are talking about a security architecture, this is more like when we are planning to build a software. But when we are talking about security architecture throughout an organization, what you see in the left side, it makes much more sense. So first we identify the business drivers and objectives. Then we determine the approach, like what are the security attributes which we need to have. Once we identify the security attributes, we build a security architectural plan where we develop an architectural framework. We identify the business needs, which we develop the architectural framework which is going to suit the business needs and goals. And finally we review and revise and improvise to achieve the organization to help the organization to achieve their vision and mission. So that is what your high level of security architectural modeling is all about. So now when we talk about the security architectural modeling in much more detailed way, so what is the first thing we do? First we analyze of an analysis of design requirement, where we understand, document the customer goals and system needs through various sources such as RFP, SOW, then contract system specifications, SLA. We validate the data. We do the valuation of the data. We assess the importance and sensitivity of the data to inform the security measures. We design the architecture. So here we do the high level product architectural design. We understand the security controls. We understand like what if we are building a software, what kind of security controls or security standards we need. So like if we are planning to build a payment application which is going to process credit card transactions, then we need to comply with the PCI DSS standard, right? So now if we are talking about building an application which is going to process PCI credit card data, we also need to make sure that when we are talking about the data, that is your data in transit, data in use, data at rest, everything should be encrypted by an FIPS 140-3 cryptographic modules. So all these requirements we need to identify when we are on the requirement gathering stage. When we are in the requirement gathering stage, that time itself we need to identify all this. Okay, along with that, we also need to do the assessment of security design effectiveness, where we evaluate how well the security design protects the system. We need to identify the attack vectors, identify potential methods of attack to enhance the defensive strategies. So now how do we identify the attack vectors? One live example that we identify the attack vectors is by using threat modeling. So we have a different kind of threat modeling approach which are available. So like we have a stride, we have a dread, we have a pasta. So stride here stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Now when we are talking about pasta, it is process of attack simulation and threat analysis. So we have a different kind of threat modeling approach which we identify, which we use to identify the attack vectors. So now if I have to translate this into the OSI layers, so in the OSI layer, we have application, presentation, session, transport, network, data link, and physical. So application layer directly talks with the software application layer, where we identify the directory services, email, network management, file transfer, file web pages, database access. When we talk about presentation layer, here we are talking about formats which needs to be presented between the application layer attributes. So we have your data translation, compression, encryption, decryption, formatting. Then in the session layer, we talk about managing the connections between the local and remote. In the transport, we do the end-to-end transport services, where we do the segmentation, multiplexing, connection orientation, and all. We route the packets, we switch it, and finally we manage the physical connection. So this is when you are talking about your security architectural modeling. It should not be only related to the software, it should be also related to the hardware, along with all the application or components which are integrated with the system, or which are going to be integrated with the system. Okay, so that is what your security architectural modeling is all about. So now if we have to take a example or overview of a security architecture, okay, so the security architecture involves the design and structure of security controls and measures within an organization IT infrastructure. It encompasses the framework, strategies, and process which is used to protect the information systems, to ensure the confidentiality, integrity, and availability of information by implementing security measures which are aligned with the organization goals. So the phase one is, first we develop. Now what is the thing which we develop? We develop the policies. In order to support the policies, we develop the standards. Then we develop the procedures and the baselines. So if we talk about even from the documentation point of view, so first we need to have a policy, then we need to have a standard, then we have a procedure, then we have a baseline. So these all three things, policy, standard, procedure, and baseline, these four documents are very, very important for every organization. And guideline is something which is, you have to remember, guideline is something which is optional, it is not mandatory. Guideline is something which is optional, it is not mandatory, but for every organization we must have a policy, standard, procedure, and baseline. Okay, now when we are talking about security architecture, so the security architecture are implemented in two ways. One is your top down approach, which is, we can say, 80 to 90% of the time majority of your organizations follows your top down approach only, where we determine the high level objectives, and then policies are created which translates them into the detailed security measures. Then we define the business objectives, identify the requirements, design the high level security architecture, and then implement the specific security controls. We ensure alignment with the business goals, comprehensive view of security requirement, And we also identify the challenges which is requires thorough understanding of the organizational objective. So majority of the time, even if you are thinking this from a GRC professional, governance risk compliance professional, normally we follow the top down approach. So where we engage with the stakeholders, senior management, or we engage with the senior management stakeholders, and we define a policy, and then we identify the detailed security requirements, and we translate it into the organizational process. But along with that top down approach, we also have a bottom up approach. But the reason why majority of the organizations follow the top down approach is because the top down approach is much more aligned with the vision and mission of the organization. So when we are talking about your bottom up approach, it begins with the existing security controls and infrastructure, which is built up to create a security architecture. We assess the current security measures, identify the gaps, and develop a security architecture which is based on the existing assets and control. Leverage the existing infrastructure may be more practical in some scenarios. It might miss broader organizational need, which can lead to a piecemeal solutions. So it is not necessary that every time when you are using a bottom up approach, okay, so where your SOC analysis or your system engineers, server engineers, network engineers, when they try to implement the control using a bottom up approach, it's not necessary that every time that will be aligned with the vision and mission of the organization. Okay, so that is the reason why 90% of the time we follow the top down approach, not the bottom up approach. Now when we are talking about your security architecture, so we have a something called as a risk based approach. So now what do you mean by risk based approach? This risk based approach means where the organization is defining security architecture. The organization is defining the security architecture which is focused on identifying and mitigating the risk to the organizational information system. So like, let's say one live example I can take, like you have your data center. Okay, you have built your data center on in such a location which is prone to earthquake, or which is prone to tornado activity. So we need to define a risk based approach where our focus is to mitigate, only we to build a architecture which can mitigate the risks which the organization is facing. Okay, so in order to mitigate, now it is not every time it is not needed that it has to be a natural risk. It can be a criminal risk, it can be in a form of security incident, like your organization is very prone or it is very vulnerable for DDoS attacks. So we need to identify and mitigate the common security incidents or risk which your organization faces. So in order to identify or mitigate the risk, first we need to conduct the risk assessment. We need to prioritize the risk, we need to build a design architecture, and then we need to do the risk mitigation. Now this is something which every risk analyst, when we are talking about conducting a risk assessment to prioritize the risk, see, it is not possible to mitigate all types of risk which the organization is identified, right? So now when we are talking about conducting the risk assessment, it is not possible to mitigate all the risks which we have identified. So we need to prioritize what are the risks which we need to mitigate first. Okay, so we need to prioritize, and in accordance to that we need to mitigate it. Now obviously after you implement controls, there will be some risk which will be left. Now once you have mitigated the risk, and whatever residual risk is left, you need to again conduct the risk assessment to identify that whether it is below the risk appetite level of your organization. If it is below your risk appetite level, you can actually go ahead and accept the risk. But if it is again exceeding your risk appetite level of your organization, then definitely you need compensating controls to bring the risk below the risk tolerance level or below the risk appetite level of the organization. Are we clear? So basically in the risk based approach, we focus on identifying and mitigating the risk specifically which the organization faces. So we conduct the risk assessment, we tailor our security architecture to address specific threats and vulnerabilities and prioritize resources effectively. Okay, so our security architecture, or you can say our security plan, is only focused about specific threats and vulnerabilities which are topmost in our organization. Okay, in that cases we will use a security architecture, but we will be more focused on a risk based approach. We require accurate risk assessment which can be reactive or proactive. Now when we are talking about risk assessment, we have a qualitative base and quantitative base of risk assessment. The answer is we have a qualitative and quantitative base of risk assessment. So if you see over here in the right hand side, we have a customer, we conducted a risk assessment. Okay, we identified low, medium, high risk, we determine the risk treatment and ongoing, and then we consistently monitor the risk to make sure that whatever controls we have implemented, whether that controls has been effective or not. Now when we are talking about risk treatment, so we have like avoid, right? We have mitigate, we have transfer, then we have accept. So these are the risk treatment approach we have. Now the same way how we have a risk based approach, we also have something called as a model driven approach. So if you remember, when I started, I mentioned that there are two types of architecture, right? We have an enterprise architecture. So for enterprise architecture, we have your Zachman, we have your TOGAF, okay, we have your SABSA. SABSA is more aligned with the security architecture. Okay, SABSA is more aligned with your security architecture. So now when we are talking about your model driven approach, okay, now when we are talking about your model driven approach, so now when we are talking about model driven approach, it uses formal models and frameworks to design and evaluate the security architecture. So we employ models like SABSA, Zachman, and TOGAF to structure and guide the security design. Then we provide a structured and standardized approach which facilitates communication and understanding, and it can be complex, may require specialized knowledge. So people who are building the security architecture, they must have a good understanding about the infrastructure, data, network, applications, what kind of devices people are using, to connect to the organization, how the organization is, validating their identity. All these factors must be taken into the consideration when we are talking about, you know building a security architecture, like when we are talking about using your SABSA, Zachman, TOGAF and all. We also have something called as a compliance based security architecture. Means what? Compliance based security architecture means where, so now when we are talking about your compliance based, okay, compliance based means where we are focused on meeting the regulatory and compliance requirements for security. Okay, so now when we are talking about your compliance based approach, so focus on meeting regulatory and compliance requirement for security. So live example, if your organization is collecting PII data of EU citizens, okay, if your organization is collecting PII data of EU citizens, then definitely you need to be compliant with the GDPR regulation, right? Now, if your organization is processing credit card transactions, definitely they have to comply with the PCI DSS standard. So where our security architecture is built on meeting the compliance based approach. Okay, so we have applicable regulations like GDPR, HIPAA. So we design the architecture where we can meet these requirements, and to ensure ongoing compliance, we ensure adherence to legal and regulatory requirements, which reduces the risk of non-compliance. And we identify the challenges. Regulations can be complex and change frequently, which can lead to compliance driven rather than risk driven design. So these are the compliance based security architecture. And finally, we have an integrated approach where we combine elements from various approaches to create a comprehensive security architecture. Okay, where we talk about the blend or top down bottom-up, risk-based and compliance-based elements to address multiple aspects of security. It balances different perspectives and requirement, flexible and adaptable. It requires careful coordination and integration can be resource intensive. Like I can give you when we are talking about framework. Okay, so where we are talking about user. Now, if you see this, in this we have a SASE architecture, modern user provisioning, advanced threat detection, and also zero trust model. Can we say this is like, so live example when we are talking about framework? Okay, can we say your COBIT is a perfect example of a framework, right? Your COBIT is a perfect example of your framework. So when you want to have an integrated approach where you want to your security blueprint to have everything which your organization needs, rather than implementing the standard word by word, line by line, you can go for an integrated security framework. Like you can use COBIT. COBIT is basically your GRC framework which we have. So now when we are talking about your identifying the security architecture approach, so we have a SABSA, which is a framework which is developing, which is used for risk-driven enterprise security architectures. We have a ZACMAN, which is used for organizing and analyzing the enterprise architecture. Then we have a TOGAF, which is a comprehensive framework for developing and managing the enterprise. And then finally, we have a NIST SP 800-53, which we talks about the security and privacy controls for the federal information systems and organizations. So this is a live example of a TOGAF. Okay, so where we have an architectural vision. Okay, first we define the architecture, then we determine the business architecture, information system architecture, then we define the technologies. So live example, we identify the technologies like identity and access management. Okay, then we identify what are the opportunities and solutions we have, then we do the migration planning, we implement governance, and once the system is translated into the production environment, we do the architectural and change management. Now normally I take each and every topic, this itself I take almost half an hour to explain, but because of the time constraints, I'll not be able to explain this in a detailed way. That's the reason why I'm cut shorting it. Okay, just a second. Now when we are talking about your architecture, we also have something called as a SOA. SOA stands for your service oriented architecture. But before me explaining SOA, so what is the ultimate purpose of using SOA? See, service oriented architecture team is basically a method of software development. Earlier, we used to use the service oriented architecture for software development. So where software components, where we, so in SOA, the software components, or you can say the libraries which we use in the software, we call that as services to create business applications. Okay, so one of the advantage. Okay, so each and every service, now if I have to give you a live example, so this go to meeting in which you people are attending this session. Okay, in this go to meeting itself, there is a different kind of modules which we have, right? There is a module using which I am sharing the screen. There is a module using which you are able to attend the audio and video bridge. Okay, there is a module which is specifically used for recording. There is a module by which I can able to see your chats, right? So this each and every modules which we are using in this go to meeting, it is called as my components, which is used to create business applications. Okay, so one of the advantages team when we use SOA is, in SOA we can reuse the services in different systems or combine several independent services to perform complex tasks. So one live example I can give you when we talk about your service oriented architecture is, when we talk about building any application. Now it can be any application, it can be my web application, it can be my software. When we talk about using any application, every application requires a user authentication functionality, right? Even your whatsapp, your Facebook, or let's say your LinkedIn, they also require a user authentication functionality. Or let's say if I am trying to build a ticketing tool, Like if I'm talking about ServiceNow, if I'm talking about Salesforce, even ServiceNow and Salesforce, they require user authentication functionality. So instead of, what is the benefit of using an SOA? The benefit of using an SOA is, instead of rewriting the authentication code for all business process. Now, if I go with the traditional way, let's say if I am planning to build a ticketing tool like ServiceNow, okay, or if I am planning to build a CyberArk vault solution, okay, I have to build, in order to use the authentication, I have to rewrite the authentication code for all the different applications which I am trying to host in my cloud environment. But what is the advantage of using service oriented architecture is, instead of writing the authentication code for all the business process, I am going to create a single authentication service and reuse it for all applications. Live example, you are using your Active Directory, you are using your LDAP, you are using your identity as a service, where you are integrating your applications. It can be your Docker, it can be your Kubernetes, it can be your AWS, whichever cloud solutions you are using. Finally, you are able to integrate it with a single authentication service, which is called as your Active Directory. This is where we are talking about your service oriented architecture. So basically, you can say an organization enterprise architecture is built on TOGAF, but in order to align with the information security, we use the SABSA. Clear? I hope that answers your question. So one another example of a service oriented architecture I can take is when we are talking about healthcare industry. When we are talking about your healthcare industry, in healthcare, we have to handle data related to the patient management system, for which we require an electronic health records, right? So I can simply, so rather than building a specific module for managing the electronic health record, what I can do is I can create, I can use a common service which can perform the patient registration task. So one of the benefits of using your service oriented architecture, one of the benefits of using service oriented architecture in your healthcare industry is, in healthcare, where I am talking about patient management systems and EHR systems, where I need to register. Instead of creating individually systems, I can create a common service which will perform the registration task automatically. So that is the advantage of using service oriented architecture. That is the advantage of using service oriented architecture. So if you see over here, service design and management focuses on creating and managing services that are offered across a network, allowing for integration and reuse. Service integration aims to improve efficiency by enabling different services to interact and work together. Live example, if you see in Office 365, when we talk about your email, your email, your Microsoft Teams, SharePoint, OneDrive, OneNote, they all offered as a perfect suite of application which coexist with each other. This is actually done with the help of your service oriented architecture only. If I have to take another example, your Apple ecosystem, okay, where all Apple devices, they coexist with each other in a much more friendly way, that is actually built on your service oriented architecture only. So these are reusable components designed to perform business functions. So there are key standards which includes web services, choreography, description language, web service description language, which help define how services interact and communicate. Security considerations, what when we talk about an SOA, is address authentication, verifying the integrity of users or system, authorization, granting access to resources based on permissions, and data protection, securing data through XML based encryption. So that is the benefit of using SOA. So now if you see over here in the right hand side of the diagram, we have a user and admin. So we have a framework configuration which is used for configuration management. So where we have a request controller, service proxy, configuration manager, which is by which we are able to access the services. Okay, then we have a Docker as well. Okay, where we are talking about enabler registry, where with the help of Docker we are able to identify the services, we are doing performance management, we are monitoring the services, reporting into a dashboard, we are implementing environment setup using instance management. all these are, so basically you can say your cloud is a perfect example of a service oriented architecture team. So now the next important element which we have to discuss is your IoT, Internet of Things. So interconnected devices and sensors deals with a vast network of devices and sensors that communicate and interact. Today we majorly use a concept which is called as smart homes, right? Where we have a smart refrigerator, smart washing machine, okay, then we also have your smart LEDs, we have your virtual reality, live example of a virtual reality, which is available in the Apple website in US, that is your Apple Vision Pro. These are all basically built upon your IoT, Internet of Things. So when you are using IoT devices within your organization or within your home, they are interconnected devices and sensors which deals with a vast network of devices and sensors that communicate and interact. Nowadays we are also seeing the IoT devices when you are using cars like Audi, BMW, or Mercedes. In these kind of cars also we have your IoT devices, not these. So basically there is a smart driving functionality which is programmed, so which is, if you are talking about in the US and all, so where if you are tired, you just program, you just enter the destination and the car is self driven, no one has to drive, people can sit in the back and take rest. So these kind of technologies are available which are all implemented with the help of your IoT only. So when we talk about integration and management, it focuses on the integration and management of these IoT devices. However, using IoT devices has its own risk factor. So it includes sensors which are gather data, actuators which take actions based on data, and communication protocols. It understands protocols like MQTT, message queuing, telemetry, transport, and COPE, constrained application protocol that facilitate communication between IoT devices. Now, when we are talking about your security considerations, key issues include devices authentication, ensuring that devices are legitimate, data integrity, ensuring data is accurate and untampered, and secure communication channels protecting data transmitted between devices. So now, even if we are talking about yours, when we talk about your IoT devices, okay, can we say your IoT devices? One another live example of your IoT devices is your Fitbit tracker, which you wear, or your Apple Watch, or your Samsung smartwatch. They are also a live example of your IoT devices only, right? IoT embedded devices. So when we are using the IoT embedded devices, what is the biggest threat, risk factor which we are there? Because when we are wearing this kind of smartwatch, which is collecting our health specific data, we need to protect that data. So we need to have a strong confidentiality and integrity. So when you are using IoT devices within your organization, we have to always make sure that any unneeded services which are enabled in the IoT devices, it should be disabled, right? Any services which you are not using, it should be disabled. Okay, one of the primary factor of IoT devices is the patching. A vendor doesn't releases frequent patches, so there might be some vulnerabilities or threats which can remain which can remain vulnerable because there is no patch available from the vendor to fix those vulnerabilities or to fix those gaps. Okay, so patching and updating the IoT devices always presents a major challenge. Protecting the confidentiality and integrity of the data is topmost when we are talking about on IoT devices. Another thing is, when you are using IoT devices, it should be always placed behind your firewall. Okay, so let's say if you have a firewall, your IoT and ICS devices should never be accessed. Your IoT devices should never be accessed directly from the internet. It should be always behind a proxy or behind a firewall. It should not be directly accessible. Even your nowadays the devices which is provided to us, like when we purchase a Geo fiber connection or Tata Sky fiber, the Geo and Tata Sky fiber, nowadays they're providing the set top box, right? So where the set top box has the set top box or your Apple TV, your Amazon Fire Sticks. These are all live examples of your IoT devices only, which has to be placed behind the firewall. We have to make sure that these devices are not directly accessible over the internet, because then if it is directly accessible, then anyone can take control of it and they can actually see what is happening within our organization. So these are some major challenges when we talk about from a IoT perspective. Now when we talk about ICS, okay, now both people who are preparing, I repeat, people who are preparing for the CISSP, CCSP, and along with your ISSAP, in all these certifications, the security architectural modeling, that is the SABSA, and the models like what we discussed, risk driven, compliance driven, data driven, okay, and IoT ICS devices, okay, all these are testable in the exam. So you people who are preparing for these, make sure that you pay a good amount of attention on these specific topics: IoT, ICS, then your SOA, service oriented architecture, then along with your SABSA architecture, the frameworks of SABSA, like your risk driven, data driven, compliance driven, all these are testable in the exam. Now, when I am talking about your ICS, supervisory control and data acquisition, it's an industrial process control and monitoring which is focused on the systems which are used to control and monitor the industrial process. It can be your hardware and software. It can include various hardware and software components which are used in the industrial setting. But the $1,000,000 question is, where we use your SCADA devices, where SCADA devices can be used. So live example team, where SCADA devices can be used. It can be used in oil and gas pipeline monitoring control, plant factory automation, water and wastewater, water treatment centers, electrical power grids, gas fire, agriculture, irrigation, manufacturing, food and beverage, pharmaceutical, all these places, team, we are using the SCADA devices. Now, what is the primary risk factor of SCADA? The primary risk factor of SCADA is SCADA doesn't have any security functionality embedded with them. So they either use the DNP3 protocol or they use the Modbus. And the problem with these both protocols is they don't provide encryption. So when we are talking about that in our organization, when we are planning to use SCADA devices, we have to make sure that the SCADA devices should be physically isolated from your TCP IP network. In a nutshell, I can say your SCADA devices should be air gapped. You guys must have seen there is a Mission Impossible Tom Cruise movie, which is, where Tom Cruise tries to, hack what do you call that, an air gap system. So what do you mean by air gap? Air gap means it is physically and logically isolated. Let me just show you that this thing if I have. So this is the one which I was referring to. You see this air gapping? Someone is trying to, hack the particular air gap system which is physically and logically isolated. So when we are talking about live example of all your IoT devices should be totally air gapped. It should not be physically accessible. Okay, so just by having logical isolation, like by creating VLANs or by creating VPCs or VNet, is not going to help over here. We need to have a physical isolation as well. So components includes your PLC, programmable logical controllers. We have a remote terminal units, and we have a HMI interfaces which are used for process control and monitoring. Okay, with the help of PLC, programmable logical controller, your PLC is reported to a centralized server, centralized console. So if you see, we have a supervisor network SCADA. All your PLC is reported to this, and it is all your industrial equipments are managed from here only. All your industrial equipments are managed from here. So the protocols which we used is Modbus, DNP3, which are used for communication with the industrial control systems. Security consideration, it emphasizes physical security. protecting the hardware, network segmentation, separating different parts of the network to limit exposure, and anomaly detection, identifying unusual behavior that could indicate a security issue. So any question in the exam talking about, okay, any question in the exam talking about SCADA, what sort of measures shall be taken in Wi-Fi? When we are talking about industrial Wi-Fi, in industrial Wi-Fi live example, we have to make sure, Ananta, that in the industrial Wi-Fi, we have to make sure that we only people who are authenticated users, their authentication should be done with the LDAP or Active Directory. Okay, we must have your how to secure remote access for OT device. We shall just wait. I'm coming to that question only. Okay, so now when we are talking about like using your LDAP or Active Directory, then using your NPS devices, which performs health checks on the endpoints which are trying to connect. So let's say if your endpoint is missing a patch or antivirus or anti-malware is not updated, then redirecting them to the remediation servers group where they can download all the patches and install it, and then authorizing them to connect to the network. These are some measures which we can take to protect the corporate Wi-Fi. So ideally, if you are talking about how to use a secure remote access for OT device, we make sure that if you want someone to access the OT device, then there has to be a jump server or a landing server from where only the landing server or jump server should be able to access the OT devices. There should be encryption for both data at rest and data in transit. We need to have a strong anti-malware, antivirus solutions. Clipboard sharing, copy and paste should be blocked. Internet access on that jump server should be completely restricted. There should not be any internet access which should be there. So these are some measures or controls which you can use if you are connecting through remote on a OT device. So as you can see, before SOA and after SOA, what is the difference? So as you can see, before SOA, we have a service scheduling, checking customer status, determining the product availability, for order processing, for account management. We were having application dependent business functions. Now what we have done, we have broken down this into small units. So we have order processing, we have account management, we have service scheduling, and each of them are running, they are trying to reuse the business service. So where we are creating the invoice, customer status, check order status, check the credit history, check inventory. So where we are reusing the existing services with the help of SOA. So this is the advantage of using SOA, service oriented architecture. Okay, so TOGAF is like you have to go for the open group foundation. So we have your TOGAF practitioner and TOGAF foundation level certifications which are there. So what I would recommend is, first if you want to go for enterprise architect certifications, then first you go for the TOGAF, both foundation and practitioner. And then once you are done with that, you can go for the SABSA. But ideally, technically speaking, that SABSA, if a person has an enterprise architecture certification, if your goal is to become a security architect, then you don't have to go for SABSA, because SABSA, unless and until your company is sponsoring, SABSA certification can be very expensive. Yeah. So if you are planning to go for certifications like TOGAF, then you don't really need to go for SABSA, because more or less it is the same thing. And plus, if you are targeting certifications like ISSAP of ISC Square, in that itself your SABSA architecture is cleared. Okay, so you don't have to go specifically for that.